Let me just tell you what we have discussed in the last session. So yes, those who are present or those who might have gone through the last session's recording, you must have found out that we were discussing about NumPy, right? And yes, please check in WhatsApp group. I have already sent a link to download the notes regarding NumPy, right? So as we decided that we are going to discuss about these four packages. Right? Today we will finish NumPy and we'll start with the next one, that is Pandas, which is also I think very important, right? So just check in WhatsApp group. You must have received a link to download the notes or the code regarding NumPy. Whatever I'm sharing, I'm using here, same thing is given there, right? And let me tell you, some people were asking that they were not able to open the files which I have shared. See, what you need to do is, I will just show you that. I have already asked, right, whether you people have Anaconda installed or not, or in the first session itself, you already see how to install it for those who are not aware about it, right? So you just need to start Anaconda. How to start it? Just go here and Anaconda Navigator. You will be able to. This is for those people who are having difficulty to open the files, right? Now I have shared a zip file with you. So you need to do what? You just need to unzip that particular file at any location, right? So suppose we have unzipped that. So go here in Anaconda Navigator and just launch this one, Jupyter Notebook. See, for that matter, you can make use of Jupyter Lab, you can make use of some other notebook, right? Or you can make use of other tools also. That's possible. But yes, I already told you that I'll be making use of Jupyter Notebook, right? So yes, just go and just click on that launch, and you will be able to see something like this. Right. Now what to do here? So for example, in my case, the zip file which you got, right? So I also have the same file and I have unzipped it, for example. So where is that file saved? So I will go to that location. So in my case, that particular file is saved somewhere in this folder. I will go to this folder, I will open this folder, right? So I already told you, Jupyter Notebook stores or saves the program files to .ipy indexation, right? Interactive pattern notebook. So see, this is the zip folder I am able to see here. Just click on this and you will be able to see all the IPY files related to NumPy. So this is how you can open it, right? So whatever I can remember in the last session, what we have discussed was we were talking about NumPy indexing and selection. So I think it was done, right? This was done, and I think NumPy operations was the topic which we were trying to discuss. And like how to do different operations. Like for example, how to find out square root, how to find out the sign of a number, how to find out the log of a number, right? All those things we will discuss. Let me show you what we discussed till now. And I think many of you are able to answer the question, right, which we try to discuss here. So how to index questions related to indexing and selection. We already talked about that. But yes, remember that this is like indexing and selection is going to be very important. So this is what we have actually discussed, and this is what you will be able to see in these notes. So I have given very good links here. For example, this one is going to tell you why NumPy, right? So just go and click on those links, right? Official page of NumPy package. All these things we already talked about, right? Reshape, random numbers, how to generate rand int, leave space. Just remember all these things, right? A range, zeros and ones, right? These are the things we have seen. And then we talked about indexing and selection. So in case of indexing and selection, I told you how to index an element, right? Whether if you want to index adjacent elements, what to do in that case. So talking about this particular thing, indexing and selection. So here we have seen bracket indexing and selection, right? Broadcasting we talked about. Indexing a 2D array. I hope you could remember this. So these are some of the important things which you need to know about NumPy. And now talking about NumPy operations. So you can add array plus array, right? So see this one. Suppose let me show you why we are actually discussing this. So let me go here and let me open the new notebook. Okay. So obviously, as usual, I need to go and I need to import NumPy. So import number as NP. So what you can do? What you can do with the help of array? So you can do all the operations on the array. Now you understand this one, right? A range. A range is what? It's a method. It's a method available because of NumPy package, right? So NP is nothing but NumPy. So NP dot a range 0, 10. Now you know what it is going to give 0, 10. So it's going to generate an array in which I will be having 10 numbers from 0 to 9. That is total 10 numbers. So let me go. Let me measure it. This is how your ARR looks like. So what is shown here in this notes is different operations. So I mean to say you can do addition, you can do subtraction on array. But if you go, yeah, this one also is possible. Because what's going to happen is 0 plus 0, 1 plus 1, 2 plus 2, and so on. You are going to get this particular result. Same number minus same number, obviously you are going to get 0. This is nothing but multiplication, right? Similarly, you go and you apply any operation. Suppose AR star star. Now you know star star is nothing but the ratio. But if I go here and if I try to write down ARR divided by ARR, now what's going to happen is we know that in case of ARR, our ARR is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, definitely, if I try to do something like this, so here it will be 0 by 0. That condition is going to come here. 0 divided by 0. So in case of 0 divided by 0, you are going to get NaN. That is not a number, right? So why? Because you are going to get a warning here. See, for other operations, it is going to show you the result, but wherever you are going to get some warning, it's going to show the warning also. So invalid error encountered, right, in true divide. This particular thing you are able to see invalid value encountered in true divide. So it's like a divide by 0. So entry point for launching and have pattern kernel. But still, as it is not possible, but still you are able to see the result here. So I mean to say you will be able to see warning here. Suppose if I do something like this. So in this case, again divide by 0, right? So 2 divide. So you got infinity, divide by 0. So again you are going to get warning. So which is nothing but divide by 0 encountered in 2 divide. And yes, same thing if you go and if you try to do it for suppose log. If you try to find out np.log, it's available in NumPy. So np.log of ARR. So again, here it is going to be log of 0, and log of 0 we know, log of 0 is this one, right? Infinity. So again, you are going to get warning. So yes, NumPy is able to detect all those warnings. Right? And yes, in this kind of cases, it is going to show you warning also, but it is going to perform the operation. So yes, obviously it should be np.sign. I'll be able to see this particular thing. And that's what is actually shown here. So remember, all these operations are possible with help of NumPy. Talking about universal array functions, same thing, np dot square root, np dot sign, np dot exponentiation, right, max, all this is possible. Okay. I think this is what we have seen in the last session. Now let me go and let me show you exercise about NumPy. And once we are done with this, then we will move to the next important package, and that is nothing but Pandas. Pandas is going to be very important when we deal with different types of data. That's what we will be discussing. So I hope now, as you already have all these notes regarding NumPy, so you will go and you will try to solve all these things, right? Suppose create an array of 10 zeros. So what should be done in this case? I want to create an array of 10 zeros. So if you remember something like np.zeros, right? This is what you need to make. So what I want is I want you to click which method should you use. I'm not saying that you should remember all the methods. No, at least some of the important methods you should be aware of. So this is the answer of that question, right? np.0 is going to give me 10 zeros. np.0 of 10 is going to give me 10 zeros. Similarly, np.1 of 10, right? It is going to give me 10 ones. So np.1 of 10. Right? So there is only 0s and 1s. It's not like that if I ask you 5s, so 10 5s if I ask you. So np.5s. Nothing is there. You just need to go and you can do it like this. So you will get 10 5s. Or maybe you could have done it like this, right? Multiplication and 5. So you will get the same answer. Okay. Create an array of 10 5s. This is what I have to do. Create an array of integers from 10 to 50. Now, can anyone tell me what command should I done here to get this kind of answer? To answer this question, create an array of integers from 10 to 50. Again, a simple thing. We already talked about this. Can anyone just let me know? Create an array of integers from 10 to 50. That means should start 10. End at 50. That means last number should be this one. See. So what should be your command? And see, it's a 1D array. This one, right? Okay. So unit is saying np.arrange 10, 51. So it should be 10, 51, right? Because higher value is there going to be included. Let me check it. So this is what Unis has given the answer. So yes, it is right. I hope other people are also able to understand that. Right? np.arrange, that is array range 10, 51. Similarly, create an array of all even integers from 10 to 50. Now what should be done in this case? Even integers. So what we have to do is, as they are asking about even integers, so 10, 51, 2, right? So if you remember, what were the arguments, right? So this 10 is nothing but start, this 51 is nothing but the stop, and this 2 is nothing but the step. So this is going to give me the answer to print all the even integers from 10 to 50, right? So you can see, because the step size is 2, that's why we got 10 plus 2 12, 12 plus 2 14, 14 plus 2 16, and so on till 50. So this is the answer for this particular question. Create an array of even integers from 10 to 50. Okay. Now just check this one. Create a 3 by 3 matrix with values ranging from 0 to 8. What should I do? Can anyone give the answer for this? Create a 3 by 3 matrix with values ranging from 0 to 8. So what to do in this case? See, intentionally I am going through all these questions. I just want whether people have, I just want to know whether people have understood the things which we have discussed previously or not. Maybe some of you, one or two people might be knowing about it, but I want everyone to learn to know about NumPy, because NumPy, see, even in your syllabus, we go and check, they have mentioned the topics which are related to neural network, right, or deep learning, basically I can say. So whenever you talk about neural network or deep learning, NumPy is going to be required. See, all these things you can check. These are the topics which are related to deep learning, recurrent neural network, long short-term memory. So obviously, whether it's a machine learning or deep learning, you are going to require NumPy. So yes, can you tell me how to get this kind of a matrix? What should be the command?
np.range 9, then reshape 3 by 3.
np.range, right?
A
No,
range.
A range. It should be A range. It should not be range, right? So np.a range 9. If I do, what I will get is 0 to 8, right? So what do we want?
Then
Reshape.
reshape 3, 3. np.reshape 3, 3.
Now we need to reshape it. So you have to know reshape this reshape method. So we want 3 by 3 array. That's it. You will get that. So just check. We have converted this 1D array into 2D array. That is 3 rows and 3 columns. Next one. Identity matrix, you know, right? Create an identity matrix like this. So the command is what? np.i. So this is nothing but np.i. You got the identity matrix. It's going to be. Okay, let's try to move and take these questions. Okay, what is the command for this? Use NumPy to generate an array of 25 random numbers sampled from standard normal distribution. So can anyone remember how to generate the numbers from standard normal distribution? I think I discussed about what is standard normal distribution. At least I give you an idea how it looks like the distribution, right? Whenever you get a bell-shaped curve, right, it's a standard normal distribution. So what is the command to get the numbers from standard normal distribution? That means the distribution should be like this, symmetrical. So anyone remember what was the name of the method? Okay, I think I got the answer.
np.random.rand.
So np.random.rand.
Yes.
Yes, both of you are right. So see, np.random.randn. So So it always gives you numbers. It always gives you random numbers from standard normal distribution, or we call it as Gaussian distribution. How many numbers you want? 25, right? So what I will do is 25 here. So np dot n dot n. Now see, and just check that it's a only I. Okay. Moving to the next one. Okay, they are saying create the following matrix. You need to create this kind of matrix. Just observe what type of values are there. 0.01, 0.02, 0.03, 4, 5, 6, 7, 8, 9, 0.1. First row. Second row 0.11, 0.12, 0.13, and so on, 0.2. So like this, last row if I go 0.91, 0.92, 93, and so on. Again, basics of number you need to make it. I hope you will be able to do this one also. Can anyone tell me what will be the answer for this to create an array like this? What should you make use of? I hope everyone understood the question, right? You just try to observe what type of numbers are there. This is the array you need to generate, right? So the purpose is just to make you aware, right? How you can make use of all the methods which we have studied till now. So can you tell me what is the relation? What can you observe from this? What type of relation you can see in these numbers? Do you remember something which we talked about? Or at least can anyone let me know about the method which I can make use of here to solve this kind of question? Yes, right, Anisha. Lean space. Lean space also you can make use of. But again, not compulsory, okay? It's not like that you can make use of only lean space to solve this type of questions. You can make use of other things also. See, what we want is, we want this kind of array. 0.1, 0.01, 0.0, 0.03. Why she said lean space? Because you can check the difference between the previous number and the next number. You check any number, the difference is same, 0.01. Difference between these two, 0.01, 0.01. Difference between any number, any consecutive number is 0.01. So they are on the they are linearly spaced numbers. So if you remember something like lean space, right? Np dot lean space. Yes, that can solve your problem here. So see, np dot lean space. Now, what is given to us? They are saying you can go, if you go and if you count number of rows 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 rows and 10 columns if you count it. So I want 100 numbers, right? If 10 rows, 10 columns is 100 numbers. What I will do is np dot lean space. Yes, yes. Again, let me know, people. If you people are aware about this, let me know. This is just I am trying to revise the things whatever I have discussed. So yes, I got some answer from some of you. This is what that person is saying. np dot arrange reshape 10 comma 10 into 10, then raised to minus 2. This is what here. So you can check it whether this one and this one is same or not. 0.01, 0.02, 0.2, and so. Yes, you can check it. This is the required answer. So yes, this is right. Whosoever has given the answer, that's right. Right? Now let's try to see what is the difference. So yes, Avinash, that's right. Let me show you what are the differences. So least space, what you can do is np dot least space. Now how many numbers we want? We want 100 numbers, right? So maybe I can start with 0 suppose. Suppose I can edit 1 and let me check 100. So this is something like this I want, right? But you can check it. They have given us the starting point and the ending point. So what I will do is I will start with 0.01 itself directly, and I want to end at 1. Now I can check. So least space is directly going to be that. But here you can check I am getting what 0.11, and see one more point is that it is giving me one dimension there. So yes, you can actually change that. That is possible. So here what I can do is instead of ending at, so with the help of lean space, as we want 1 here, let me check in the question. So as we want 1 here, accordingly we can give the value. So what I can do is I want 100 linearly spaced numbers between 0.01 and 1. So maybe I can go and I can reshape it something like this, right? Now you can check you got the answer. So yes, least space also can do that. What is another way to do this? So another way is something like this. But again, you don't have to do this kind of a thing. That means you can apply some other operations. Now what I mean to say is np dot average. Okay, how many numbers I want? I want to generate 100 numbers. Right. So maybe starting with as it is given starting C, he is starting with 1 and ending at 0.01. Why? Because starting is not from 0. It is from 0.01 in the question. So I can also do the same thing 1 comma 101. Why 101? Because we know last number what happens, right? So a range and something like this. So I got all these numbers. Now again it's a 1D array, right? So I can go and I can reshape it maybe 10 by 10. If it's 100, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. Right? I got 100 numbers like this. After that, what I can do is, if I go and if I try to divide it by 100, am I not getting the answer? So yes, this is also giving us the same answer. Right? So there are different ways to do the same thing. That's what I want to say. So like this, I hope you people will go through the remaining questions. Okay, all these things are possible. So solution is also given to you, and questions are also given to you. I hope you will go through that. Now let me start with Pandas package. Okay, Pandas, I will be sending it to you. I will be sending all the notes related to Pandas. So Pandas is again very important package. Let me show you. What happens is, see, as per your syllabus, we need to understand some algorithms, right? So depending on some algorithms, as I told you that we will be talking about some applications. We will try to create some applications, right? And we will try to deploy the applications onto cloud. But whenever we go for creating some application, we need data, and data can be in any format. Data can be in CSV format, data can be from Excel file, data can be from TXT file, or data can be from some database, some external source. So to fetch the data from that external source and import it in Python, or maybe with the help of some other language. So to import it, you need some package. In case of Python, specifically it is Pandas package which is going to do that. That's the basic one, right? So let me give you a basic introduction about Pandas, and then let's try to see the use of that. So you can see here, it is mentioned that Pandas, you can think of Pandas as a powerful version of Excel. I hope you might have come across Excel many times, right? So it's a powerful version of Excel with a lot more features. So what am I going to do is, these are the topics which I am going to discuss related to Pandas package. So you can see here, we will see what is series, data frames, how to handle missing data, how to group by with the help of pandas, merging, joining, concatenating. Maybe we might not require this particular thing as per your syllabus, but yeah, we will try to see some examples based on that. And then how to do some operations, and finally we will try to talk about different data input and output. Right. So how to handle different types of data with the help of pandas package. That's what we will be. That's what we are going to discuss. So let me go here and let me talk about series. So series is a very basic thing when we talk about pandas package. Let me tell you, suppose there is some Excel file or there is a CSV file, right? Comma separated value. So you are going to fetch the data from that external source. So what happens is, whatever you are going to fetch with the help of pandas package, that is going to be a data frame in Python, right? And data frame is actually a collection of series. See, basically we want to understand an important thing in pandas package, and that is nothing but data frame. But data frame is actually a series. For time being, we can imagine this data frame as a table. You can think of this thing as a table, right? And each column of the table you can think of as a series. I hope I'm clear, right? So data frame, you can think of it as a table, and each column from the data frame, you can think of that as a series. Let me show you. So yes, later on you can go through all these things, and whether it's a Pandas package, Matplotlib package, Seaborn, NumPy is going to be a base package, right? NumPy is going to act as a base package for all of them. So let's start. Let's start with the Pandas package itself. Let's see some basic things in Pandas package. Let's start with the series. So as usual, I'm going to import Pandas package. Right? So import Pandas as PD. So as in my case, it's already installed. I'm not going to see any error, and it should be imported successfully. Right? So you can check it. It is imported. Now, as we want to discuss about series, so let me go and let me try to create some data structures here. Okay. So I hope now these are the basic things which we have seen in basics of Python. I hope you will be able to understand what are all these things. I am trying to create a list called as labels. Okay. This one is also a list called as my list. What is this ARR? It's a NumPy array which we are trying to create. And what is this D? D is a dictionary. Okay? We know that dictionaries are always enclosed in curly brackets, and it's a key value pair. Right. So let me press Shift Enter, and yes, you will be able to see all the variables, all the data structures, whatever we have created. So labels and my list are the lists which we have created. Right. We are going to need all these things to understand Pandas package. Right. So this is my ARR, which is an array, and this is dictionary. So if you want to check, right. So if you want to check, suppose what is this my list? It's a list, right? Type command we already talked about. Suppose I want to say what is ARR, this is my array, and similarly, what is that T? So it's a dictionary. So we have different data structures actually. Now, what are we going to do is we are going to make use of those data structures to create the series first. So how to create a series? So for example, as I shown you, this is a list, right? So what I will be doing is out of all these data structures, out of all these variables, whatever we have created, so we are going to make use some of them as data and some of them as index. So labels is ABC, labels is ABC list, and my list is 10, 20, and 30 list. Now how to create a data set? How to create a series? So here's a command pd.series. Right. So we make use of a method called as series, and we pass some arguments to this. Now, which are the arguments we try to pass? So there's an argument like data, and there's an argument like index. These are two important arguments that we pass. So for example, I want to pass labels as data. Okay. So what I will do is pd.series of labels, comma, and I want to give this 10, 20, 30 as index. So what I will do is I will try to pass that particular thing. That's it. This is going to create a series. See, this 10, 20, and 30 is index. So always remember how do we pass the arguments in case of series is this is data. Okay, and this is going to be series. So now, sorry, not series, I should have written a index. This is going to be index. Okay, now just try to check whatever was there in my list. What is there in my list? 10, 20, 30. So 10, 20, 30 is showing you index, and this labels is what? Labels is ABC. So that is going to be the data. So this is called as series. Right? I could have actually assigned this particular thing to some variable also. Yes, that's also possible. Suppose let me run this particular thing. See, even if I could have done it like this. So what I want is I want data as labels, right? And I want index as my list. So see, that's also possible, right? So data is always first. Again, if you do not want to keep this one as first, you just need to write down data equal to or index equal to. Or otherwise, you could have written like this. But see, as I am trying to create a series with data and labels, but suppose if I just pass it like this, so what it is going to do is not data actually, it should be my list. So now check what's happening here. Now you can see that in my list, what was there in my list? It's a list of 10, 20, 30, these three elements. But I did not pass index, right? I did not pass a value for index. So you can check that if I am passing only one argument, so that will be data, right? But what is the index in that case? So by default, index is going to be 0, 1, and 2. That's why if you people remember, right, in earlier sessions I told you that in case of Python, index always starts with 0. So if you are not giving any index, by default it is going to be 0, 1, 2, right? Same here, what I could have done is instead of my list, if I want labels here. So yes, you will be getting labels, but index is going to be 0, 1, 2 only, and data is going to be ABC. Now you can check it, right? 0, 1, 2 and ABC. If you do not give index, no problem. By default, index is going to be 0, 1, 2. Right. Now let's check about what happens in case of array and dictionary. If this is my array, now what I want to do is I want to create a series. I want to create a series and I want to keep data from the array and maybe index from the labels. I want to keep that. Now see, index is ABC. You can check it. A, B, C is the index and data is 10, 20, 30. Because in array also, what do we have is 10, 20, 30. Right? Next thing is, let's check what happens in case of dictionary. Now see, we know that dictionary is a key value here, right? What do we have in case of a dictionary? Let me show you. This D is a dictionary which we created. Now in our dictionary you can check. What do we have? A20, B20, C20. Now always remember, whenever we try to convert a dictionary into a series, these keys are going to act as index by default. See, let me show it to you. If I go and if I try to run it now, see A, B, and C is index. From where it got? So see, this A, this is B, and this is C. So in case of dictionary, always remember keys will be taken as or will be considered as indexes, right? And value is going to be data. So this is how you can convert maybe a list into a series or array into a series or a dictionary into a series. Or even I could have sorry, now if you want to check what is S1, so it is a series, right? Let me just show it to you. You can check it. This is a series. S1 is a series actually. But what we want to basically understand, we want to understand data frame. But data frame is a collection of series. And that's why we are just trying to discuss a basic thing, and that is a simple series. I hope everyone is able to understand what's a series. Okay. So I told you, just to make the thing simple, you can imagine a series as a one column from the data. That's it. So whatever I told you till now, all the things are mentioned in these groups, right? So data in series, this is what we have seen. Even one more important point about series is that series can identify the keywords. For example, there's this functions or methods, see, sum, print, and length. These are some of the functions or methods which are available in Python. So what am I trying to do here? I am trying to pass a list of all these functions or methods to a series. That means I am passing it as a data. Let me if I go and if I run it, you can check. Index is 0, 1, 2 by default, but as this is a built-in function, so series is able to identify that okay, it's a built-in function sum, it's a built-in function print, it's a built-in function. So remember that particular point that series can identify the inbuilt methods of the function. Now using index. Now how to make use of an index in case of series? So for that, let me create two series. Okay, let me create two series, series 1 and series 2, and let's see how index are useful in case of series. See, what is series 1? I am creating a series 1 as pd.series. What is this? 1, 2, 3. It's a list. But this list we are passing as what we are trying to pass it as a data. Okay, and what is this particular thing? This particular thing is we are trying to pass it as an index. Yes, it is again given here, right? It's an index. That means what are we going to get as output? So our index is going to be USA, Germany, USSR, and Japan, and the values are going to be 1, 2, 3, 4. Right? So series 1 is going to be something like this. Okay, let me show it to you. Let me run this particular thing. Now this is my series 1. Okay, let me run series 1. So you can check it. Indexes are US, Germany, USSR, and Japan, and values are or the data is 1, 2, 3, 4 respectively. Similarly, I will go and I will try to create one more series, and that is nothing but series 2. And let's see how indexes are going to be useful for different operations on series. So this is my series 2. Now you can check difference between series 1 and series 2. So just try to compare what's the difference between series 1 and series 2. In series 1, if you see, you have USA, Germany, USSR, and Japan. Right. In series 2, USA, Germany, Italy, and Japan. That means this USSR, this one, right, it is not present in series 2. And here this Italy is not present in series 1. So that's the difference. Now what am I going to do is, suppose if I go and if I try to add these two series, that is series 1 and series 2. So if I try to do some operation like series 1 plus series 2, now wherever this index is going to match, that particular operation is going to be performed. Suppose series 1 plus series 2, it's going to give me what? USA. So here USA is there, here USA is there. So 1 plus 1 is what? 2. Germany, Germany. So 2 plus 2 is what? 4. USSR, USSR is not here. Now always remember what's going to happen is 3 plus null. I hope you people are aware about null value. Can anyone tell me what is the result of 3 plus null? What is the result of 3 plus null? What this null signifies? You might have come across this particular value many times. What is this null? What do you think? What it is going to give me? 3 plus null, or for that matter, 100 plus null. What is the result of this one?
Null value.
It's a null value. Always remember, any arithmetic operation with null always results into null. And that's a big problem. Some of you might be knowing that in Oracle database there was a problem, but yes, later on they actually removed that. But as any arithmetic operation with null always results into null, so it might cause a very big problem later on, maybe in different projects, different domains. That's why it's necessary to remove those things. That's what we will be doing in this meeting. But here you can see that as USR index is here, but USR index is not here. So that means you are going to get the USSR, right? Something like this USSR, and here you will be able to get NA or not, something like this. Right? So this is how index is going to work. So arithmetic operation, if it is a null value, arithmetic operation is also going to work out. Series 1 plus series 2. Now if I go and if I try to show you, see, you can check the this result of series 1 and series 2 is Germany 4, but Italy is NA. NA is nothing but something similar to null only, or not a number, I can say. Right? Japan, USSR, and same thing is for USSR. So why we got NaN value in case of Italy and USSR? Because Italy and USSR, this kind of index was present in one section, not in two, right? And if at another place, if it is not present, something related to that particular index, if it is not matching, obviously the value will be considered as null or NA or missing value, I can say. And any arithmetic operation with null value always results into null, and that's why we got something like this, right? So this is the way the indexes are going to work in case of series. And yes, you can do this kind of indexing, whatever we have been doing till now, right? Suppose this is my series 1, right? So you can go and you can apply indexing and series 1. Suppose I want to go for USA, so you can check it. I can index the values, right? So this is a simple thing about series. Always remember this one. Those who are not aware about, or those who are learning this particular thing first time. Series you can imagine it as one column in the complete table. Okay, so it will help you to answer different questions later on. That's why I'm trying to do it. Okay, so that was all about series. Let me go to the next topic, and that is nothing but data. So data frame is the thing which we are going to get ultimately, right? Whether it's a CSV file, if you are trying to import, ultimately it will be taken as a data frame. Right? So let's see now. Even suppose if you are going to fetch some data from HTML web page, right, from website, in that case also you will see that that will be imported as a data frame. And that's why it's very important to know about some basic operations which you can go and which you can apply on data. Right? So you can see that data frames are the workhorse of Pandas and are directly inspired by R programming. Maybe some of you might be aware about R programming language. In R also one can make use of data frame. Actually, data frame is a concept from R language, right? And again, even there are some algorithms which they have mentioned. Suppose if you want to create a model with the help of some algorithm, so same thing you can do it in R, right? So there are some methods which are available in R language also, with the help of which you can implement different algorithms, or you can create models, right? And even obviously you can make use of Python. So data frame, talking about data frame concept, actually it is taken from R programming language, right? Now let us try to understand data frame. So for that, yes, pandas and numpy are already imported. Let me go and let me create. Let me generate the name. Let me generate some random number. See, I hope you people understand this one also. Okay, it is not compulsory that you should also run the command like this. I hope you people are getting whatever is going on here. This particular. So if you do not want to type random dot rand n again and again, np dot random dot rand n again and again, and if you just want to run random, you can run this command. Otherwise, you can type, for example, rand n 5, 4. What is the meaning of this? The meaning of this one is np dot random dot random. So if you do not want to type np dot random before this one, then you need to fire this particular method. That's the only thing. And I hope you might be knowing this seed method. I hope you are aware about the seed. What that seed is and what the number inside the seed signifies. Let me see. Suppose if I am generating this one, you know, right? np dot random dot rand. In questions also we have discussed that. So rand generates numbers from standard normal distribution. Suppose if I go and if I type 5, so I am going to get some positive and some negative numbers. That is from standard normal distribution or Gaussian distribution. So what is that seed? What is that seed is going to be? See, before that, let me show it once again. I will run the same command. If I run this command, I will again get 5 random numbers from standard normal distribution. But this time I will get different random numbers. 5 numbers, but yes, different random numbers. Again, if I go and if I run it again, I will get different random numbers. But now, where is that seed coming into picture? So np dot seed. np dot random dot seed. Yeah. np dot random dot seed. What is the meaning of this one? Suppose if I go and if I try to run it like this, put it. Now see what's going to happen. These are the random numbers which are generated, right? After that, I am trying to execute np.random.seed, put it, run it. After that, I am once again running this particular command. Okay. Now I got which number? 0.4, minus 0.13, 0.64, and so on. Let me run this command once again. Seed command once again. Okay. Run it. And what I will do now is I will run np.random.rand5 once again. So what's going to happen is this time I am not going to get different numbers. This time I am going to get same numbers. That's the use of np.random.seed. You can see these numbers and these numbers are same. That's because of this seed command. I hope you people are able to understand. If you need any difficulty, just let me know. Okay. But
Sir, why 42?
okay, again, instead of this 42, even if I go and I try to write down some another number, no problem. See, if I go here, that seed command is going to go the same way. Now, why this 42 is? If I go here, let me show you what's going to happen. Now see, here numbers were like this. Now here I got different numbers, right? But after this one, if I run this particular command once again, 1000 only, and then again run this rand 5 and then 5, then I will get same numbers. See, this one. So what this number signifies is that this number inside the seed signifies the variety of the values which you want to generate with the help of random. Are you getting my point?
Yes, sir.
But if you run seed command with the same number inside the bracket, you are going to get the same. I hope it's clear, right?
Yes, sir.
So let me tell you in real time where do we make use of that. So many times what happens is we need to check the output for the model. Right. So in that case, what do is we need to check the output for the same data again. So in that case, we make use of this seed command. So in short, I can say that dot seed is used to take a control on the number of on the variety of random values which are going to be generated with the help of random. Right? Just to take a control. Otherwise, this 1000 value it can be 1000, 10,000, 2, 0, whatever you want. You can no problem. And when we will be learning about how to create the models with the help of different machine learning techniques, at that time, just remember that you need to split your data into training and testing. So while splitting your data into training and testing, you make use of this particular seed. Remember that. At that time, you will be able to, you are going to see this kind of a thing in your code. Okay, that's why I'm just trying to make the things clear here itself. Still, so suppose I have 500 records in my data. Out of 500 records, generally what we do is 70% data we take it as training and 30% data we take it as testing. Again, why 70-30? I will talk about that in detail. It's not a hard and fast rule that it should be 70-30. So 70% of 500, that is 350 number of records I will take it as training data. Now, those 350 number of records which I am going to make use of to train the model with the help of some machine learning algorithm like linear regression, support vector machine, or any other algorithm like decision tree. Those 350 number of records should not be in sequence. They should be random, right? So they should be random, but in what fashion? How much random they should be? So that will be decided by this sequence. So maybe you will be able to make sense whatever I am trying to talk about. You will be able to make sense about all these things once you see your first model, okay, or maybe first application I can say. But remember, yes, this is because of NumPy only, and in NumPy we have this count just to take control over the random data generated. Okay. Now what we want to understand is we want to know how to create data frame, right? Before that, let me tell you what is this. I hope you will be able to tell me what is the output of what will be the output of this one. Can anyone tell me what is the output of this? A space, B space, C space, D space, E dot split. What type of a data structure you will get as output?
List with A, B, C, D
Now,
as elements.
yes, you will get a list. Right. Now, why am I asking you this particular thing is because this list we are going to pass as a index or as a column in the data frame. See, actually, to create a data frame, so I want to create a data frame with the name df. Df is equal to pandas dot. This is the data pg.data. Now you might be remembering, right? If you want to know which are the arguments I can accept in a series or a data frame or any method, I can just hover my mouse here and press shift tab, and you will be able to see everything. Data is the first argument, index. Difference between series and data frame is that in case of data frame we have columns also. This was not there in case of series. In case of series, we were having data and index, but in case of data frame, we have columns. Okay. So what I can do is now what I want as a data. So for that, I am going to make use of random. So np dot random dot randn. Same thing. Whatever is given in that particular example in the notes. Okay. So here. How many rows I want, how many columns I want. So for this example, you can see I want 5 rows and 4 columns. That means 20 values. So accordingly, see, basically what we want is we want this one. We want to create something like this. Okay. So 5 rows and 4 columns are there. So that means I want 20 values. So np.random.random 20. But in what fashion I want? So I want it in as 4 rows and 5 columns. Suppose, let me show it to you. Suppose if I run this particular. Okay, I got 20 values, right? I got this 20 values. But we want these 20 values in this fashion, right? That's why. So this is just an example. Okay, see, we already are aware about that. We want the data in 5 rows and 4 columns. Ultimately, values are going to be 20, right? So what I will do is 5 comma. If I go and if I run this particular thing, now say I got it. Right? So it's an array, 2-dimensional array. Same thing I am going to pass. So this is going to be my data. Next is what? What I want as the index. Just now I have shown. We want index as this list, right? So that's why I'm going to pass index equal to this one. And yes, the next one is columns. I will also create the same data, whatever is here. So the next one is W, X, Y, and Z. And here split by default split method actually gives the output in terms of list. Same thing I am going to show. That's this is going to create the data. If I go and if I try to create here, you will be able to see over here. This is your data. So if you want to check what is the type, right, it's going to show you a data frame. So I told you, data frame is going to be collection of series, right? So this is your data frame. Now on the basis of the data frame, you will try to see different methods which can be applied. So you can check it now. A, B, C, D, E is a row and W, X, Y, Z is a column. And these are the values which we have generated with the help of. We generated values ourselves. Later on, what's going to happen is we are going to fetch the data from some external source. Try to understand. Okay. Now here, if I want to know which operations I can apply on this, so just go here df dot replace pattern. We'll be able to see different methods which can be applied on data. This is what we are going to see now. Like for example, how to fetch a particular value. Right. Suppose what I want is df dot loc. Loc stands for location. So df dot or maybe let me try it out something like this. df dot loc of a and run it. Or maybe loc only I should use. Loc stands for location. df dot loc of suppose. Let me go to that cell once again. Yeah. So df dot loc of suppose column. Just a column. Okay, so I'm doing. Okay, keyword error W. Let me see. Go here and let's see how it is going to take the So access a group of rows and columns by labels or boolean name. So LOC data frame name is here. Suppose if I go and if I try to make use of W, it should give me the answer. So let me try out ILOC index location. Let me make it as 1. Let's see. Okay. So now whatever you are able to see this one, what is this actually? So you can check what I have given 1. So 0, 1, 2, 3, and 4. Right now I have given 1. So what I got is 0 0.7, 2.5, 1.0 minus 1.8. 0 0.7, 2.5, 1.0 minus 1.8. That means I got this completed, which is at index 1. Index 1. Right. So ILOC stands for index location. What I was trying to show you is, let me go here and df dot loc. So with the help of loc, if I want to show you the same thing, I need to give label. Let's see. Now see, same answer I got, but instead of going and giving index location, right, I am giving label, index label. Otherwise, in both the cases, you can check the answer is same. Right? So LOC stands for location and ILOC stands for index location. This is what you are doing. So like this, we want to learn which are the different methods which we can apply on data frame. And this is very important. See, why is it important? Because this is the thing which is going to help us to understand our data better. Right? So maybe it's a text data, maybe it's numerical data, it's image data, whatever it may be. We need to apply different operations on the data. Right? So once this is ready, let me go and index. Yeah, this is what I was trying to show you again. Also, LOC, ILOC we have seen. Let me try to show you df of W. So what it is going to give me? It is going to give me all the values from W column. Right? See, W column, you can check what are the values in W column. So 0.17, minus 0.74, 0.64, and so on. Minus 0.17 and so on, 64 and so on, right? So this is how it's going to show me all the values from one column. I want to check 2 columns at time. We need to go 2 square brackets. Suppose I want to see what is the value of W and maybe Z. Let me check W and Z. Now see, I am able to see this one. Now can you people tell me, if I go and if I try to check what is the type of this particular thing, what should be the answer here? What is the type of this one?
Series.
It's a series. It should be, right? It's a series because I already told you data frame is nothing but the collection of series, right? And what is the type of this particular thing?
Data frame.
Now try to understand. It's a data frame because I told you only one column is a series. But it's a combination of two columns. It's going to be a data frame. Or I can say combination of series is going to be a data frame. So in this case, it should show me a data frame. That's a basic difference. You can try to understand. Very basic thing, but yes, important. This is going to definitely help, right? So, what is a series and what is a data frame? I hope people are able to understand that. Now, with the help of this, maybe whatever we have seen, right? This one. If I go, suppose maybe df of w, you know that it is done. But if I go and if I try to apply some operator, df of w greater than suppose 0. Now see what it is going to give me. So in case of W, there is no value. In data frame W, there is no value which is greater than, in this W column, there is no value which is greater than 0. And that's why everywhere I am able to see false, 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 false. Let's try to check for, let's try to check for X column. Now see, there is only one value which is not greater than 0. Other values are greater than 0. So this one, and this one. So I hope you people are able to understand how to make use of this kind of operations. Okay. Now here what I can do is, as this one is showing me, this is also indexing. Okay, as this particular thing is showing me true or false according to this particular condition. But what if I want to see the actual values? So yes, you can do that. Let me copy this. Okay. And if I go and df of that particular count. So wherever it's a false, it's not going to show me the value. Wherever it is true, that value is going to be shown. See. Now check it. What has happened? So what I have done is df of x greater than 0. Now df of x is greater than 0. What am I doing? See, what I have done is df of x greater than 0. Now df of x greater than 0 was showing us this one. False, true, 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 true. Now, for which condition it is false, you can check it. So, for this row A, it is false. So, it means what am I doing is, now, wherever this is not greater than 0, do not show that row, show all the other rows. So, wherever this x is not greater than 0, only show those things. Not greater than 0, do not show that particular thing. Same thing is happened here. See. So from the complete data frame, I am able to see only those rows where value of x is greater than 0. That is the meaning of this particular. Right? That's what you can do with the help of index. Similarly, suppose if I want to apply the condition on two columns, or maybe from this one also, if I want to see a particular thing, that's also possible, and that is what is actually showing you. See here. The WZ we have seen. Again, see, this is also one way to access the column. But yes, this is not recommended. See, df of W, you can do it. Or df, always try to make use of, instead of this, always try to make use of square bracket. This is what is recommended. But dot notation is also possible. But do not make use of dot, use square bracket. Okay. So, what we were trying to talk about was, okay, this particular thing, I will try to talk about that. Yes, I was talking about location allocation. I told you. This is the thing I was talking about. So you can see df of W greater than 0. So if you do it for complete data, right? So it's going to check each and every value, each and every cell, whether it is greater than 0 or not, right? And accordingly, you can go and you can apply the condition. This is also possible. In our case, what we have done is we have checked where df of x is greater than 0 or not. That's also possible. And accordingly, we have actually seen different values. See, this is what we have done now. Now you can go further and you can index further. This is also possible. So in our case, what I mean to say is, this is what we are trying to do. Out of this, what do you want? Whether you want only x, only w, only y, or only z, Yes, that's also possible. So here if I go and if I try to copy this particular command, from all these results, suppose I want only y. So yes, that's possible. It means what? It means for whatever the values where x is greater than 0. From that, I want to check all the y values. I want to see all the y's where x is greater than 0. This is the answer for that. I want to see all the y values where x is greater than 0. This is the answer. Right? So here I was applying it for only one column. As it is shown in your notes, you can go and you can apply for complete data frame. Now see, df is greater than 0. So wherever it is greater than 0, it is going to show you true. At all other places, you will be able to see false. What we can do is we can go further and we can apply the same thing on this complete condition. So wherever it is greater than 0, you will be able to see the actual value. Otherwise, if that condition is not satisfied, you will be able to see null or any. So yes, there are different ways which you can apply here. See, this is what is shown. So these things we have seen. What is this one now? So you can see this particular command. Exactly same thing. Whatever is this. Here I wanted to check only y. Maybe you might want to check one more variable. So I will go with y as well as suppose z. So show me the value of y and value of z wherever x is greater than. You'll be able to see this one. So simple index, right? That's what is shown. Now, one more important point about data frames is that how to add a new column and how to change the index in the data frame. That is again using. See, this one I am talking about. So this is the way how you can add a new data frame. Let me show you our complete data frame first. See, this is our data frame. Okay, df. This is our data frame. Now what I want to do is I want to add a new column in our data frame with the name new. Now what do we have in our data frame right now? We have w, x, y, and z. Similarly, we want to add one more column, and that is nothing but new. And what is new? New is nothing but addition of w and y. Okay, so let me run it. Now if I go and if I try to check df, I can see that new is there. Okay, new is there. So check it. New is there by default. Now let's try to see how to apply operation like df.drop. Suppose I want to drop it. So what you can do is df.drop and name of that particular column. Okay. df of new not found in axis. So it is saying that df of new is not found in axis. So we need to give maybe in numpy. I think we have come across this particular axis. Or if not, let me tell you what is axis. There is always an option which is called as axis. So what is the axis? You always remember this. Whenever we say axis equal to 0, that 0 is nothing but we are talking about row. And wherever we say axis equal to 1, that means we are talking about columns. Remember this. Okay. So this kind of a parameter we are going to see number of methods. Axis 0 means row and axis 1 means column. So here I am getting error because I did not mention whether I am talking about rows or columns. I want to drop a column or I want to drop a row. So I want to drop column. New is a column. That's why I will write down x is equal to 1 and then run it. Now you can check it. See, there is no new column. It is dropped from here. You can see. Earlier it was there. Now after df drop, no, it's not there. But if I go once again, if I try to check once again, you can see df dot drop. Even if I done this, but after that I am able to see you once again. Let me run. Let me show it to you. If I run it, see new is there. It is not dropped. So this is just for temporary purpose I can see. So why we are able to see this? Because whenever I will do some operation like df dot drop, okay. So df dot drop, if I am doing, I need to mention an option, and that is nothing but in place. So by default, in place is false. You need to make it as true. Let me show it to you. df dot drop. What I want to drop? New. It's a column. That's why I will write an x equal to 1. And I want to do it permanent. I want to drop it permanently. That's why you should mention in place. By default, in place is false. If you want to check it, go raise shift tab, and you will be able to see argument, and that in place argument by default it is going to be false, and that's why. See, you can check it. In place is false by default. So what you need to do here is you need to go and you need to make it as true. That's it, and then run this command. And then after this point, after this particular point, you can go and you can check df. Now you will not be able to see new, because now new is permanently deleted or permanently dropped. You see, it's not there. I will go and I will run it once again. Suppose definitely you will not be able to see the new command because it is dropped permanently. So remember, in place. In place is the argument which to make it as true. Okay. You see if something is remaining from this one. This is what we have seen. Here, yes, in this we have seen. And same thing is for, see, if you want to remove row, some rules. So suppose how to remove a column I have to repeat. Same is the thing for removing the dropping the row. So df dot drop. Suppose I want to drop d row. If I go like this, definitely I will see. I will be getting something like this, right? But let me go and let me check it. But it is again not for permanent, right? I will have to make in place equal to true. This particular command df dot drop, I could have run it like this. This is equal to 0. This will also run because 0 talks about what? 0 means row and 1 means column. Value of axis and term. Okay. So this is what df is. Okay. Any difficulty anyone? I can see. People are leaving. There are only 11 people I can see. When I started, there were 18 people. Just let me ask you once again. Are you aware about all these things? Just can you please let me know clearly? I know that yesterday I was not able to conduct session on time. That's why you people to come here and attend the session, right? So is it because of timing, or are you not getting anything, or you are already aware about it? Can you people just let me know? Otherwise, if you are aware about all these things, I will not discuss.
Actually, sir, some students are comfortable in the recording version also. That is also a reason. And some people face network issue also.
Okay. So maybe I think then I should not share the recording in 1 or 2 days only, right? I should wait for that. Otherwise, people will not attend the live sessions. Why am I saying this? Because see, if you have any doubt, you can ask doubt here. That's why. That's the reason. I hope that should be the reason. Okay, if you have any other difficulty, just let me know. I'm asking you again repeatedly. Okay, anyway, but I think I can continue, right? Till 2 o'clock as we have decided. You don't have any session or something like that. No problem, right?
No problem.
Okay. So yes, a data frame I was talking about. So remember that in place by default is false. You need to make it as true if you want to perform some action for permanent, right? That's the thing you have to remember. And axis equal to 0 for row and axis equal to 1 for column. Now let me see. Okay, selecting rows. This one I have already talked about. Df.loc. LOC stands for location. ILOC stands for index location. Okay, this is also I have shown you. And again, if you want to go and if you want to index based on some row and column, that's also possible. So if this is my df, whatever you are able to see, if I go here and if I write down df of, I want the value from suppose C row and suppose y column. Let's see. Give brackets. Okay, let me give df dot what's happening there? Okay, I am getting the answer, but it is saying okay, re-index as alternative. Passing list likes 2.loc. Obviously, ILOC is index location. This is not going to work. What's happening here? Same thing I have done, right? So it's giving me a warning in this case. df dot location of. Okay, this is what I was trying to see. What's happening is C and Y. So C and Y. I should get this particular value. Right? This is what I was trying. df.loc location. So I got this particular value. Similarly, if you want 2 rows, 2 columns, that's also possible. Like this one. This is what I was talking about. So just remember that if you want only one value, see, I have only one square value. If you want 2 rows, 2 columns, or maybe 3 rows, 3 columns, something like that, you have to make it like this. So df.loc location, it's going to show just that. Right? So see, here the data set is very small, okay? And maybe when you will try to import some CSV files, or maybe when you will try to take some data or import some data from some HTML pages or XML pages, in that case, obviously, the data is going to be bigger. Condition selection, we have talked about this. We have seen examples. There is something called as XS, I want to tell you. That is cross section. This one also we talked about. See, this is the thing, but and I hope you are aware of it. And just a simple condition. Yeah, reset index. Let's say this one now. df.reset index. Now, in our case, so here we will try to see how to change the index. In our case, if you go and if you try to see what is the index right now, the index is A, B, C, D, E. What if I want to change that index and I want to make some other column as an index? So that's what we will try to see now how to do that. So here df.reset underscore index, we have something like this. Reset underscore index, if I go and if I try to do, now you can check it. Instead of A, B, C, D, E, I'm able to see the original index, that is 0, 1, 2, 3, 4. A, B, C, D is still in the index only, but it is going to show the original index. So what we're going to do here is we are going to add a new column in our data frame, and that column we are going to make as an index of our data. That's what we are going to do here. So let me create a data set. See, this you are aware about now. So CA, NY, WY, so California, New York, Washington. So again, it's the same thing whatever we had done earlier. I'm just trying to create a list. Okay? New index is going to be a list here. Okay, new index is a list. Now this particular index we are going to add it as a column, and I'm going to name that column as states. So df of states is equal to new index. Now after this point, what going to happen is in your df you will be able to see something like this. So now you can check WXYZ and states, and in states we have California, New York, Washington, and so on. Right? So let me check it once again. Now this is what your new data frame is. Now what we want to do? Now we want to make this states column. We want to make this states column as an index here. This is what we want to do. So for that, there is a command, there is a method called as df.set underscore index. This one. This is what I am going to make it. Okay? So df.set underscore index, and whatever the column you want to set as index, the name of that particular column. In our case, the name of the column is states. So if I go and if I try to run it, you will be able to see that the states is going to be the index. So you can check it. Index. Right? A, B, C, D, E is not now index. This is going to be index. Whatever the value in state, I will say index. But if I once again come, if I run it, now you can see that states is not an index. Even though the previous command created states as an index, but I once again came here and tried to check it. Can you guess what's the problem? Why I'm not able to see the updated index? Or what should I do? What should I have done? I want states as an index. I got it as an index, but second time if I try to check df now original data frame, I am not able to see states as an index. Can you guess? Can you people guess what's the problem here? Just now we talked about the concept
In place.
in place, because we did not make in place equal to true. I already told you that in place by default is false. So you need to go and you need to make in place as true. That was the problem. Otherwise, so that means if you want to make this states as permanent index, you should go and you should try to do this equal to this one. So if I go and if I try to make place as 2 and then save the index, after this you go and you check many times, you will see that states is going to be your index. See, right? Now states is index. So index equal to 2. That was the only problem. That's what I was missing, right? Okay. Now let's try to talk about multiple indexes or multi-index hierarchy. Now for this one, you should be aware about again some basic methods actually. Like we are going to talk about something called as zip. Okay, so we will see what is the zip and how actually it works and what is the output of zip and how it is going to be useful in case of multiple indexes. Let's try to see one by one. So here, what I will do is, I hope you people are able to understand this. See, outside is a list, inside is a list. Okay, these two lists are I am going to create, and after that I will try to talk about the methods which can help you to create the multiple indexes. Let me tell you why multiple indexes are needed. So in simple words, I can say that suppose we have a lot of data, and in that data you have multiple number of rows, huge number of rows. Okay, many number of rows. So in that type of a data, what's going to happen is actually maybe whether it's a database or whether it's some file, if you have a lot of rows like this, many number of rows, something like this. Okay. So what's going to happen is, suppose if you want to fetch this particular record, so system reads this row, then this, then this, then this, then this, and so on. So obviously, to reach to this particular thing, it needs to access everything. So it will be very time consuming, right? In that case, instead of using this kind of index, what you can do is you can make use of multiple indexes. So in short, I meant to say that multiple indexes is going to save a lot of time of searching or access time it is going to save. And that's why there is a concept of multiple indexes. Maybe we need it sometime only, or if it is dependent on data only, we have to make use of multiple indexes. But yes, there is a concept of multiple index which you can make use of. And that's what we want to understand actually. So see, here you can check. We will go step wise. We will go step by step. Here you can check outside and inside. These are the simple things which we have seen in case of basic pattern. That is nothing but these are the lists. So my outside list here you can check. Outside list looks like this, and inside list looks like this. See here, what am I trying to do is I am trying to create a data as per our name, because I want to explain the concept of multiple indexes here. That's why I am trying to create such a data which is going to help you to understand the concept. So outside G1, 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 G2, G2, G2. Inside 1, 2, 3, 1, 2, 3. These are the two lists which we have created. Ultimately, what I want to do is, see, my data is going to be something like this. See? G1, 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 then G2, G2, and G2. Then G1, 1, G1, 2, G1, 3, G2, 1, G2, 2, G2, 3. So there are 6 rows, right? Now you can see that there are some repetitions in this case. So what is that repetition? G1, G1, G1 is repeated. G2, G2, G2 is repeated. Something like this. Yeah. In this case, what I can do is, in this case, I will go like G1 and then 1, 2, 3. I will go like this, G2 and then 1, 2, 3. So this is going to be the first level of the index. This is going to be the second level of the index. Right? For example, I want to search this particular record where G2 and 2 is there. So if the data is stored something like this, so I will have to get system will get this one, this one, this one, this one, and so on. And then ultimately it will come here. But if the data is stored like this, so as it is G2, directly it will go to G2 and it will get 2. So only one read operation is required. But in this case, you can check 1, 2, 3, 4, 5 read operations are required. That's the difference. And that's why there is a concept of multiple indexes. Again, there's a limitation to that. We will talk about that now. So I hope at least you got a basic idea why. Why are we discussing the concept of multiple indexes? So in short, to save the access time, okay, or to save the search time. Okay. Now, what am I doing is, see, let me tell you, there is a command called as zip. Zip command, what it is going to do is, it is going to zip the elements together. Suppose, what am I doing is outside comma inside. Right. Zip outside comma inside. What is the output of this? So if I want to change the output of this, we have to typecast it in some data structure, maybe list or something Suppose I will typecast it in list. Whatever you are able to see here, this is what this is actually what this is nothing but it is showing you the location in hexadecimal, you can say, right? It is showing you the location where the result of zip is stored on memory. But if you want to see it here itself, you can see it. Now see G11, G12, G1, G21, G22, G23. Try to understand what zip method has done is it has given you the output as a tuple. See, this is one tuple, this is another tuple, this is another tuple. So the reason behind making use of zip command is that after this one we are going to make use of a method that is called as pd dot multi-index. So the requirement of multi-index method is that the input should be in the form of tuple. That's why we are using zip, right? So I'm just trying to talk about all these things by breaking all the commands in smaller commands, right? So I have shown you the output of zip, right? Now what I will do is I will assign that particular output to some variable that is hierarchical index, something like this. Okay. Now after that what? Now see, after that we are going to make use of multi-index. So see, pd dot multi-index, pandas dot multi-index is the method which is going to help you to create multiple indexes. Dot from tuples. So see, that's why we use zip command. From tuples. Now what are you passing it as the argument? Higher underscore index, and that is nothing but this one, right? And I am assigning that to the result to this one. So you can check it. That means I am creating a multi-hierarchical index. I hope you people are able to understand. See, this is the method multi-index from tuples. Okay, from that we are taking and higher underscore index. Higher underscore index is this one, which I have shown you just now. If I run it now, if I go for title check higher underscore index, my multiple index looks like this. Now, what is the meaning of this? So, actually, what it does is it creates some codes. See, G1 0, G1. So for example, G1 0, G1 0, G1 0, G21, 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 right? Or I think these are nothing but the codes. How many records I have? How many rows I have? 6 rows I have, right? So see, 0 0, 0 1, 0 2, 1 0, 1 1, and 1. I mean to say that it is going to create the codes. Now I will show you how the data looks like. See, till now we haven't talked about data. Till now what we have done, we only created the multiple index. Now you can make use of this multiple index in your data. Okay. So that's why we are going to need data. So what am I doing is pd.data frame. How it works, you have already seen that. What is this np.random.rand 6,2? You know that it is going to create, it is going to generate 12 values. How? 6 rows and 2 columns. See, 6 rows and 2 columns. And what is index? So here I am going to pass index as multiple index, which we just now created. And as we have 2 columns, so I am just going to name the columns as A. That's it. So this is going to create my data frame. I hope you people are able to understand this. Okay, that's why I just broken it into smaller parts. See, pd.data frame we have seen, np.random.rand and 6,2. You know that it's going to be the values. Index is hierarchical index and columns is AB. If I go and if I run it now, I will create a data frame, but this time my data frame is something like this, where I have used multiple indexes, right? So now you can check it. If my data would have been without this multiple index, and if I want to search this particular value, then it would have read this one, this one, this one, this one, and then this one. But here I want this value which is presented G2, so I will directly go. I will read this one and then this one, and I will directly get the value. Right? So this is nothing but multiple index. This is how you can make it up. So in this case, if you can check why it is called as multiple index, because there are 2 levels of index. This is the first level of index, which I can call it as a group, and this is the second level of index, which I can call it as numbers. Or even you can go and you can give them names to these indexes. I think I have shown it here also. So let me check it. df dot index underscore names. So df dot index underscore names. df dot index. Now you can check it. df.index is going to show the same. I think for names we have one method. This is our data frame. Okay, let's see. Now you can go and you can apply same method whatever we have seen till now in case of a simple data frame, right? Where we are used normal indexes. So you can see df.loc. So df.loc location of suppose I want all the data from G1. So you can check it. Everything from G1 it is going to show. So what is this? This is again a data frame. So if you want to go further and index it, right? Suppose you can go here and if you check, see you can check, you will get everything from A only. All these things are possible. df.loc, and there is something called as df.access that also will stand for now. Yeah, this is what I was looking for. df.index.names. So this is going to show you the names of the indexes. In our case, we haven't given any names to indexes. That's why it is showing me none. Right? What if I want to give the names to indexes? Yes, that's possible. This is how you can give the name. df.index.names and pass the list of the names. So names are group and number. If I go and if I run it and then go and check the data frame here, I will be able to see same indexes, but now this time there will be names, the index, group and number. Okay, so this is how you can make use of that names. And XS something like X, yeah, this is XS. There is some method which is called as XS. XS stands for cross section. So what this XS command is going to do is it is going to help you to index the data. For example, if I am doing df.access of G1 and run it, now say it's going to show me everything from G1, right? But suppose from G1 or maybe from G1 as well as G2, I want only first record. That is also possible with the help of XS, that is cross section. How to do that? See, from G1, if I want only first record, this is how I can write down with the help of cross section XS. But no, first record from G1, right? Minus 0.08, 0.64. What if I want first record from both G1 as well as G2? Yes, that's also possible. See, this is the command. I want first record from level now. That means from G1 as well as G2, I want first. So once you receive the notes for this, maybe try out your hands on all these things. I hope you will go through all these things and try to execute it, right? Because executing all these things on yourself is very important. So I'm talking about those people who might not be aware. Okay, so you can check it G1 and G2. So you are able to see first record from G1 as well as G2. If you want to just make sure if it's a first record or not, you can check. See here. Minus 0.08, 0.64, minus 0.08, 0.64, and minus 1.42, minus 0.36. Same. This is how you can make use of cross section. Okay. So that was a simple thing about data frames, right? Remember, there are a lot of methods which you can apply on data. Let me move forward. Talk about missing data. So let's see how to handle missing data in data frames, which we are going to need for all the types of data. Or we will be doing this kind of a thing again and again in pre-processing step before creating the model. So it will not take much time. This one, now you are able to understand this. I am just trying to create a data because we are going to need some data to understand the concepts. So what is this now? You can see pd.data frame. Inside data frame, what am I passing? It is a simple dictionary, right? See, you can check it in curly brackets. Whatever is included in curly brackets and whatever is written in the form of key and value pairs, it is nothing but dictionary. So what am I doing is I am just passing a dictionary as a input, as a argument to this particular data. So this is going to be my data, and I told you when you pass the dictionary as an input as an argument to a data frame, keys in that particular dictionary are going to act as index, and this is going to act as data. So what is this np.name? NumPy. NP is nothing but NumPy, NA is nothing but not a number. So it is going to help us to generate null values. Why am I generating it? Because I want to tell you how to handle the data sets where we will be able to see some null values or missing values or NA. That's why we are manually creating this kind of data sets. This is simple dictionary, okay? Just try to understand. Simple dictionary. So this is my DF data frame. Let me show it to you. Okay. where we can check. In second row we have one NA and NA, and in third row we have two NA. Now how to handle this NA? So df dot, there is something called as fill in. So if I do like this, df dot fill in, I want to fill that NA with some value. So you can fill that particular NA value with any other value. But I want to fill that value with some default value. You can check that wherever there is a NA value, that is filled with whatever the value I have. Right? Here you could have given any other value. Generally we replace the NA values with mean of that particular column or the data items. Mean is the average answer. Okay, so generally that's what we do. But fill in is the method. So we make use of to fill the NA values with whatever the value we want. Okay, so drop NA is also something we can make use of. But drop NA is going to do what? Drop NA is going to drop everything wherever there is a. So df dot drop NA. See what it has dropped. So the rows wherever it has seen any NA value, it has dropped that row. There is only one row where there is no NA, and that's why we are able to see the output as 1.2. Right? So df dot drop NA, df dot fill NA. Try to remember this. Okay. And yes, axis. I hope now you remember axis. If you want to apply according to the row or a column, you can apply. Df dot drop NA. If I go axis equal to 1. Now that means what? That means drop those columns where there are NA values and not the rows. See, that's why it has dropped column A and column B and not C. Now axis equal to 1 means what? Axis 1 means column. That means by default the value of axis is always 0. That's why we do not mention axis equal to 0. Right? I hope you understand this one. So yes, and yes, this particular thing talking about threshold. This one. What is this threshold? So see, if this is my data frame. Okay. Now what I want to do is df dot, suppose maybe here they have your threshold equal to 2. We can change this value to 3, 4, 5, 1, whatever we want. Suppose let me start with suppose 1. Df dot drop NA. So threshold, threshold. Suppose if I give threshold equal to 1, run. Now just check. I am able to see everything from original data when I done threshold equal to 1. But if I go and if I try to write down df dot drop NA, let's take threshold equal to 2. Now you can see that I am able to see only 2 rows. That means what it has done? It has dropped such a row where there were 2 NA. Let me go and let me take it once again. df dot drop NA where threshold equal to 3. Now see, I am able to see only 1 row. Okay. And if I go further, if I try to write down df dot drop NA threshold equal to 4, and then I'll be able to see empty data. Now why I did so? So just try to understand. Whenever I write down threshold equal to 2, it means show me only those rows where there are minimum 2 non-NA values. Okay, minimum 2 non-NA values. So here you can see NA value, not minimum actually. I can say with the help of this particular thing. See, these two rows. So these two rows, okay, not about NA value. So you can remember it in different ways. Just remember it like this. Show me all those rows. Okay, show me all those rows where there are minimum 2 non-NA. This is the point. Minimum 2 non-NA. So whatever the value I am trying to mention here. So how many non-NA values I want? Minimum 2 non-NA values. So 1 is here, 2 is here. That's what this row is showing. And if minimum 2 means what? Minimum 2 means it can be 2, it can be 3, it can be 4, it can be 5, and so on. Similarly, if I go and if I try to show the next thing, see. if I try to write a threshold equal to 3. What do you mean by this? It means show me all the rows where there are minimum 3 non-empty values. So what is the row where there are minimum 3 non-empty values? Only this row. That's how you are able to see only this. If I do it as 4, there is no row where there are minimum 4 non-empty values, and that's how you are able to see. So like this, if you go and if you try to do it for anything, obviously you will be getting empty data. I hope you understood the meaning of the argument threshold, right? Minimum non-end, okay? So I think that is all about missing data. Yeah, one more point is, as I told you that in real time, what do we do is we fill the NA values with mean of the column. Suppose what I mean to say is, if this is your data, now how to find out the average or the mean of any column? So you can check it. Suppose maybe df of, suppose in B I am getting some NA values, right? Here I am getting some NA values. In A also I am getting some NA values, right? Now what are we going to do is, suppose we are going to replace the NA values with the mean of this particular column or any column for that matter. For example, the mean is nothing but what? Average value. So mean of this A 1 plus 2 divided by 2, that is 1.5, is 1.5. Now what we can do is, wherever there is any missing value, we can replace that particular missing value with the mean of this particular A column. So df dot fill NA with missing value of A, with mean value of A. Now you can check. Now there is no missing value in our case. So here it was a missing value, it is filled with 1.5, 1.5, 1.5. Actually, this is a very small example, but let me tell you, in real time, always remember two things. What's going to happen? Either your data is going to be numerical data, or I can say continuous data. I hope you understand continuous numbers, right? That means maybe suppose marks or percentage of a student, right, or maybe price of house, something like this. So in that case, suppose if you have those kind of columns, and in those columns, suppose if there are some missing values or any values, always remember, in numerical or continuous kind of data, we always replace any values or missing values with mean of that particular column. Okay, mean is nothing but what? Average. But what about the categorical data or categorical columns? Now, what do you mean by categorical data or categorical columns? For example, let's take gender column. Gender is a categorical data. Suppose let possible values are male and female, right? So this is an example of a categorical data. Now, if someone is filling up some form and he forgot to write down the gender, so obviously in the database it is going to come out as a missing value. But we do not want missing value in our dataset. So how to replace missing value in this kind of a column? So always remember, whenever there is a data of type categorical data like gender column or maybe zip code, right? So in that case, you need to fill the NA value. You need to replace the NA value with mode of that data. I hope you people understand mode, right? Do you have any idea about mode? Mean mode. Are you aware about mode? What is mode? Can you just let me know?
Highest repetitive value.
So most frequent value, right? That is nothing but the mode. Right? Suppose there is a column in which first person is a female, then male, then male, then male, then female, then male. So 1, 2, 3, 4. So 4 is the mode. Oh, sorry. Male is the mode of this particular column. Right? Most frequent. And similarly, there is median also, right? So always remember, whenever there is a continuous data or numerical data, we replace the missing value with either mean or the median answer. In which case median, I will talk about that. But first of all, tell me, you are aware about median, right? What's the median? Mean is nothing but the average. What is median?
Middle value.
Suppose I have 2, 3, 5, 2, 3, 4, 7, and maybe 8. So what is the median here? Yes, someone said rightly middle value. Then what is the median here? Can yes?
4.
4. So what we will do is 2, 3, 4, 7 and 8. You arrange them in ascending or descending order. And whatever the middle element we get, that is going to be median. But what if I have something like maybe 6 here? Now what is the median in this case?
5.
No. How you found out 5? 2, 3, 4.
Mean of 4 and 6.
So mean of 4. Okay. Then that is right. 4 and 6. If you are yes. So these two middle elements you are going to find out, and then you take the average. So that's the median. The point is that remember, if it's a continuous or numerical data, we replace the missing values with mean and median, right? And if it's a categorical data like this, we replace the mean value with more. What is the limitation of mean? You might be knowing that. What is the problem with mean? What can be the problem with average or mean? So that I think you will understand why I talked about median mean. What can be the problem with mean or average? Are you people getting my question?
Null values, it will not consider.
No. Anyway, even median also will not consider null, right? But why we will not replace some missing values with mean of that one, and why you will go with median? So for that, are you aware about what is the limitation of mean or average? Basic math. What is the limitation of mean or average? What can be the problem with mean or average? Anyone? Okay. See, for example, there are different employees who are working in my company. Okay, suppose the salary of the first person is 45,000. Salary of the next person is 50,000. Some next person is 35,000. Next person is 70,000. Suppose someone's salary is 90,000. Right? Someone's salary is suppose 75,000. Okay. So these people are working. Now, if I ask you to find out the average of this, what you will do is you will add their salary and divide by total number of people, right? This is what you are going to do. But if I tell you that, so obviously it's going to give you the average salary. But if I tell you that okay, this first person, second, third, fourth, fifth, sixth, these 6 people are working in my company, plus one more person is working in my company, and whose name is Bill Gates, and his salary is something like this. And if I now ask you to find out the average salary, what's going to happen? Still you will get the average salary, but this value is drastically going to change the average. Are you getting the point? So this is going to be the extreme value for other values. That means we are not actually getting the actual average of this particular data. Are you people understanding my point? So
Yes.
my point is that average is affected by outliers. This is called as outlier or extreme value. So average is affected by outliers or extreme values. And if you get this kind of a data in your data set, in that case, you should not make use of average or a mean to replace the missing values or any values or null values in that data. In that case, one should go with mean. See, one should go with median. So obviously, you know how to find out the median. 1, 2, 3, 4, 5, 6, 7 values are there. So whatever is the middle value, you will get. Suppose let's suppose it's what is the middle value will be here? 35, 45, 50. Suppose 70. So see, at least it will give a basic idea about average salary, right? As compared to this one. Are you getting a point or not?
Yes, sir.
Yeah. So that's the problem. So in that kind of a case, one should not go with the mean. One should go with the median. Otherwise, if it's a categorical data like gender column, obviously you can go with more of that particular column. So that is all about missing data. But remember, this is very, very important. Missing data, handling of missing values is very, very, very important. It's a part of pre-processing of data. And if pre-processing is not good, your model is not good. See, anyone can create the model, but what's necessary is it should give you correct results. Accuracy should be high. Now let me show you what is the next thing I want to talk about. See, what I will be doing now is I will today evening I will be sending you this particular all the notes, all the 8 files. See, you can check. Let me tell you. See, if you see in Pandas, just check that there are 7 to 8 files which you are going to get. 1, 2, 3, 4, 5, 6, 7, 7 and 8. Okay. So out of all these things, for you people, what you should know is this one and this one. These two things I need to cover actually. Maybe group by is also important, but yeah, many times we do not make use of that. Let's see how it goes. So you are going to get all these files. I will be sending you a zip file the way I sent NumPy notes. Plus, remember that for Pandas there will be separate exercise. Okay, so there will be this exercise and this two IP files along with their solutions. Okay, but for this one you are going to require some data sets, and let me tell you, I am going to send this CSV file to you, right, and this Excel file. So this is just for your knowledge, what you will get and what you need to access. Try to understand. Okay, this Pandas files I will be sending today evening. Those who want, they can go through this. At least what till the point whatever I have covered. Okay, and for that you are going to require this particular data sets. So try to understand these are the things which you are going to require, and I hope everyone is clear how to open these files. Okay, because some people were asking me that these files they are not able to open. Obviously, you can open them. You just need to unzip the files first, and then you will be able to see a folder. Go inside that folder through Jupyter, and then open this IPVAN. Everything is given. I hope all of you are clear, right? Any doubt, anyone? Maybe those who might be using this kind of a first time, for them I am asking. Even if it's a very basic problem, please ask. No problem. Okay? So remaining things maybe we will discuss in the next session actually. Okay, if you do not have any doubt, then just send your numbers and names in the chat box, and then we will stop here. Yes, just let me know if you have any doubt. Yes, just send your numbers and names in the chat box. Okay, 1, 2, 3. I can say total 14 people are there. 5, 6, 7. Okay, I think everyone is done. Right? I can say 13. Okay, guys, then we will meet in the next session. I will be sending you all these files. Please refer it. Please fill the point whatever you have covered, and let me know if you have any kind of doubt. Maybe just let me know. Okay, guys. Bye.